Okay, some impacts that you haven't heard of. This one is starting to be called the Clovis Comet. It's thought to have essentially extended the last ice age a little bit. It was something like Tunguska, but much larger. It was over northeastern North America. It partially destabilized, which is to say it really messed up. The Laurentide ice sheet triggered an episode of global cooling called the Younger Dryas. Tremendous shockwave thermal pulse, extensive biomass burning, which is the fancy way of saying that lots of forests and grasslands burnt up. Lots of North American megafauna, as they are called, went extinct. They were probably under a lot of pressure from human hunting already, and this finished them off. It also apparently finished off the Clovis culture and most of the people then living in North America. The reason I have pictures of antelope on this slide, well, there's two reasons. One is I took these pictures, and the other is that antelope can run 60 miles an hour. There is no predator in North America that can run 60 miles an hour, but there used to be, because we used to have cheetahs. And so the antelope are kind of a remnant of an ecosystem that we used to have here. There's also an interesting story behind this one, because as you can see, this one is posing, which they don't usually do, okay? They usually do this. I took this picture in Wyoming about a month ago. And you can see quite a few antelope driving down the road in Wyoming, but I noticed that when you stop your car and get out of it and point something at them, they don't hang around. So I was lucky to get that picture. But this thing, apparently this one was raised by a local rancher. This is out of the VLA out in Mexico, which you've seen in the contact. You've seen this. And I was out there in September of '08 and was walking around taking pictures, and I turned around and there's an antelope standing about 30 feet away looking at me, which is highly unusual. And it started following me. And so I took a few pictures. It wouldn't quite let me pet it, but let me get really close. And I asked one of the technicians out there what in the world was going on, and he told me that, yeah, it's, somebody local must have raised it. It showed up a couple of days ago, okay? And which wasn't a bad strategy on its part, because it would be fairly safe hanging around the buildings from predators. They didn't have a herd to join. And then I heard from one of the other guys in the SKC a few months later. He was out there about a month later than I was. And he said not only was the antelope still hanging around, but they were having to tell visitors to keep their kids away from it because they tried to headbutt them. Apparently, it either wanted to play with them or it thought they were, competition or something. But anyway, we still have antelope, but we don't have cheetahs. So that's the takeaway from all that stuff. Here's one that's a little bit more hypothetical, but there's some evidence for. This was written up in Science News a few years ago. Apparently, somewhere out in here, I don't know exactly where, there is a crater on the seafloor, and there are deposits from tsunamis at some pretty alarmingly high altitudes above sea level in eastern Australia, somewhere over here, and also on Stewart Island. And the suggestion is this thing hit in about 1500 and raised a tsunami that was well over 100 meters in height, so more than 10 times the height of the one that hit South Asia at the end of, was that 04, I think. And the current population, of course, is much, much greater than it was in 1500. There are now a couple of 100,000 people in Hobart, and Metro Sydney is about 4 million. So if that were to happen today, the consequences would be quite a little different. Okay, here's a really fun one. This is, I know this is Bill Cook's favorite slide, or the earlier version of it was his favorite slide. There's a fairly wild hypothesis with has gotten a decidedly mixed reception, that fragments of Comet Biela may have started the Great Chicago Fire. And some of the supporting evidence for this is that there were very large simultaneous fires throughout the upper Midwest that started literally within an hour of each other that night, including the Peshtigo fire, which unless you happen to be from the Upper Peninsula of Michigan or northern Wisconsin, is probably the biggest disaster you've never heard of. It may have killed 2,500 people. So there's that idea. Let's see. Okay. And more recently, the rest of these are all going to be very recent. This is one that was written up in Sky and Telescope back in '94. It was over the South Pacific, about 100 kiloton explosion, fortunately at fairly high altitude and over the open ocean where it didn't really do anything to anybody. It was pinpointed, well, it was seen by a few fishermen, and its location was pinpointed by some early warning satellites, which is to say by spy satellites. And in fact, we had spy satellites detecting events like this all over the world in the 1960s. But the data was all classified because we didn't want to reveal what our spy satellite capabilities were. But I was later told by a former Air Force officer who worked in that program and who now is also the former Astronomical League president, a guy named Bob Gent, that the spy satellites way back then were about the same capability as the Hubble Space Telescope, long before the Hubble was orbited, but they were just pointed down instead of up. So we were seeing these things all over the world and knew that something was going on, but really couldn't announce it. But then in the 90s, they declassified a lot of the data. The interesting thing is you can infer from that if you want an idea of what the current capabilities of the National Reconnaissance Office are, just look at the next generation of space telescopes on the drawing board. Because that's what's probably already up there, just pointed down instead of up. And also remember the power law relationship earlier. If something like this happens once a decade, then there is something a tenth that big hitting us every few weeks. Okay, let's see. This is, I promised you a picture of Itokawa, and there it is. Most asteroids, most near-Earth objects, when they hit us, produce airbursts because they're not necessarily big solid hunks of rock. They're more like flying scoops of gravel. And that's essentially what this is. That's about 500 meters by 300 by about 200 meters thick. And even something fairly large can just pancake out when it hits the atmosphere and explode, so you don't always get a crater. But you can get an explosion at very low altitude that's very destructive, like Tunguska was, for example. Okay. We get more recent and a lot more close to home. Speaking of Chicago, this is one that blew up over the southern suburbs of Chicago in March of '03. They recovered hundreds of pieces of this thing. It was punching holes in people's roofs and landing in their bedrooms. Looks like, from the estimated mass and velocity, that it was about the equivalent of a semi-truckload of dynamite. Fortunately, it blew up high enough up that all we got were, some holes in roofs and things instead of an entire neighborhood getting flattened. And in the news article about it, the quote was, "This is the most densely populated region to be hit by a meteorite shower in modern times." That record stood for all of 21 months.